What's up, engineers? IndyDevDan here. Welcome to an Agentic Coding devlog. Let's start with the facts. The Claude 4.5 Sonnet release speaks for itself. It's a step change improvement that has clearly been trained for agentic tool use for agentic coding. The model itself is powerful, but when you take the model and you put it in the right agent architecture, when you put it inside Claude Code, this is where we get the best agentic coding tool by far, bar none. Codex CLI, Gemini CLI, they're nowhere near as close as you think they are. If you don't believe me, that's fine. I'm going to show you right now. And I challenge you to try to replicate just half of what you're going to see in this video with one of those tools. Spoiler alert, you won't be able to. So what are we agentic coding today? We're going to solve two problems. One in the loop on my device right here, and the other on my dedicated agent environment. What are we doing exactly? The Claude Code SDK has been migrated to the Claude Agent SDK. So I need to update one of my code bases to deprecate the old way and to use the new updated syntax and a couple of different changes here. So while we're migrating on my device, we're going to hand off some work to my agents and their dedicated device. We're going to have them build out some prototypes of the real-time agents with the OpenAI tooling. So let's hand off this prototyping task to our agents right now. Claude Code in YOLO mode here, /AFK agents. We have a reusable MCP server prompt. I am handing off work to my agents. I'm going AFK. I need to pass in a couple variables here, right? Prompt, ADW name, and documentation if we need it. Accomplish these three tasks. We have our three agents that we want to get built in three separate scripts. Be sure to quickly test to make sure they work. So we have a little closed loop structure here, a validation command inside of the high level prompt. And then I have my specific ADW plan, build, ship. Then we're passing in some documentation. This is the exact docs that you just saw. And just so you can see this, this is my agent device. And if I open up code here, when I kick this off, you're going to see this agent device. You're going to see this job get picked up. The agent device just picked this up. And now I have a fleet of agents on this device that's going to handle this job. All right. So I'm going to throw that in the background. We're going to sleep every 60 seconds, check in on the job, see how it's performing. All right. So let's open up Cursor here. This is a private proprietary code base. But you can see here we have applications and we have 8 apps. Let's fire up a Claude Code instance. I'm going to use MCP, JSON, Firecrawl. This is my Claude Code, Sonnet, and YOLO mode shorthand. Right away, the first thing I do, I always turn thinking mode on. There's no reason not to use more compute. I've done this a million times, and so have you. And so we've encoded this engineering workflow into a reusable custom / command, /scout plan build. Very simple inputs here, user prompt and documentation URLs. We can start with our documentation, grab the URL, throw that in the docs, migrate to the Claude Agent SDK. As I write these prompts at a very high level, I like to look through the exact work that I'm going to have my agents do. As you practice walking through and adopting your agent's perspective, thinking through what they're going to see, you're going to find things that they will likely miss. Sonnet 4.5 will have no problem with a lot of this, but I want to explicitly mention the system prompt is no longer the default. If you're using this SDK, you need to explicitly use this new syntax. Highlight this just specific section, pay close attention to the section to make sure our update to the new syntax. And that's it. So scout, plan, build. What does this workflow do? Let's kick it off and understand exactly what's going on here. In the beginning, I mentioned there are things that these other agentic coding tools cannot do. Let me show you exactly what I mean. So here we have a well thought out, well built, reusable agentic prompt. This is a 3-step workflow. Let me just go ahead and collapse everything so we can see this at a very high level. Purpose, variables, instructions, workflow, report. We first scout the code base for files. We then plan what needs to be done. And then we build. Why do we have this additional scout step? If you take a look at our agent execution right now, you see something really interesting. The first thing that's happening is we're running /scout. So we're using one of the brand new features out of Claude Code. You can run custom / commands inside of custom / commands. Let me say that another way. You can compose your agentic prompts. Okay, this is huge. Let's open up the workflow and understand what exactly that means. So check this out. We have a simple 3-step workflow. Now, there's a lot more details happening here, right? You can see this is all we pass in, and all of a sudden, our agent is spinning up 4 sub-agents to accomplish work on our behalf. Let's go prompt by prompt and understand how we're chaining together more compute with Claude Code 2 and Claude 4.5 Sonnet. Let's dial into our Scout prompt, right? What's going on with Scout? Search the codebase for files needed to complete the task using a fast token efficient agent. So what we're doing here is delegating the searching process from the plan step into a Scout step. If you've seen the Elite Context Engineering video, you know that what we're doing here is using the R&D framework. There are only 2 ways to manage your context window, R&D, reduce and delegate. Here, we're offloading from the plan step and having agents, 4 agents in parallel, run search for us. These are fast, cheap, but still quality models that can do tons of engineering work outside of your primary agents window. So you can see here, sub-agents have completed. You can see we had Gemini Lite run, we had Codex run from that Scout search for sub-agents that then run their own agent. We created this relevant files markdown file. Now check this out, right? Our agents have quickly searched through exactly what needs to be changed. We have the exact positioning of where we need to update these files. We scaled up our compute here to get multiple perspectives, right? So we didn't just run another Claude agent that is, highly aligned with the other Claude agents. We ran Gemini, we ran OpenCode, we ran Gemini again with the Flash preview, we ran Codex, right? And we can even run Haiku in this workflow if we want to. But so you can see that relevant files piece got created. We're now moving to step 2. Our planner read all the relevant files that our scouts put together, and now it's scraping the documentation that it needs. We want it locally for all of our agents in our pipeline moving forward. The scout prompt is going to be inside of the Building Specialized Agents code base. If you're an Agentic Horizon member, you're going to have access to this. This is one of the extended lessons. There's no reason to do this hands-on anymore. There's no reason to even prompt in the loop, but of course, I'm doing it here so we can step through it piece by piece together. Just to recap on this Scout workflow, this is something that I've been playing with to offload context from the planning step. You really want your planner's context window to be free to really focus on getting the job done, not just to look through files. Looking through files isn't exactly planning, right? Of course, they're building up the context. That's important, but this Scout build plan 3-step workflow has been really, really powerful. So I wanted to share it with you here. We're on step 2 now. During the planning, you can see we're about to write our AI docs right now. After a couple read steps, right, our agent is planning. The planner isn't as novel. You've likely seen these planner work steps before. Here's our great prompt structure. Here's our purpose, variables, instructions, workflow, report. It's pretty straightforward, right? We're going to analyze, scrape docs, design, document the plan, generate, save, and report. So we should be saving and reporting here pretty soon. When you separate your prompts like this into Scout, into plan, into build, into whatever workflows that you need for your work, you make it very easy for both you, your team, and your agents to understand what's happening. This feature out of Claude Code is incredible. You can now chain custom slash commands. That means you can chain your agentic prompts together. You can isolate and reuse even more than before. And you can use this syntax to just explicitly call these things, and the agent will know exactly what you want to do, all right? We have this composite agentic prompt. But of course, we break it down. We have /scout, plan with docs, and of course, we have our build that's going to run at the end. Actually, that should be running right now. Let's check it out. Yeah, there it is. Nice. So we should have our plan. Let's see what our plan looks like. Here we go. Typical plan. It's written up, everything that needs to happen. We are agentic coding. We're setting up the reusable primitives of agentic coding, these plans, these prompts, these reusable encodable pieces of knowledge, and we're making sure our agents know how to accomplish tasks, and we're deploying compute in a smart way, right? We can't blow up our agent's context window. And think about this workflow a little bit, because there is a problem with this workflow. You'll notice here, one agent is going to run all of these things back to back to back, all right? We'll do a /context on our single agent that's doing all of this work. And this is a big problem that we completely sidestep inside of tactical agentic coding, which we'll talk about more in just a little bit. But you can see here, our agent has read that plan back in, and now it is migrating to the new Claude Agent options. If we just, copy this and go to the docs here, you'll see this exactly. This was renamed. And so our agent is just working through all the fixes piece by piece. This is not work you should be doing. In fact, if you are prompting this work back and forth, you should be investing inside of your new prompting layer, right? You need more prompts to scale up your compute, and you want to make these reusable. Prompt engineering is critically important. It's just as important as context engineering, right? With every agent you spin up, you have to manage the core four: context, model, prompt, and now tools. You can see our plan included tests inside this code base. We have 8 custom agents, right? 8 applications. Literally, these are 8 single individual applications that our agent is updating back to back to back, making these migrations. All right. So very powerful stuff. And I can guarantee you, you're not pushing your prompts far enough, and they can do a lot more for you than you think they can. All right, let's see where our agent is at. Perfect. Critical system prompt migration. Wonderful. So it did catch this. Append system prompt needed to be replaced. Phase 5, phase 6. Okay. Wow, this is all complete. Tested Pong agent, fantastic. So I'm just gonna go ahead and say, test a few more agents that you don't need UI for. There's a couple of these agents that require UI, we're just gonna skip those. And so I can guarantee you, by the way, our agent dedicated device, it's already finished its task. If I open this up, and yeah, so you can see here, we had this agent sleep in intervals of 60 seconds and then just check the job, continuously check the current status of what agent is running in this agent pipeline. You can see there's the builder right here, and here's the shipper right here. In separate 60-second interviews, there's the status of this agentic job running on my dedicated agent device. This is super powerful, but let's just recap what happened there, right? We ran a single prompt scout plan build that kicked off a agentic prompt. Now, why do I keep saying agentic prompt? It's because we have to add weight to how capable these prompts are. We're not just talking to a chat interface with a couple of tools that runs for a little bit. These are agents in the terminal. These are agents that listen. There's high adherence to the prompt with these powerful models like Claude Sonnet. And then to push it even further, and this is why I say, Codex CLI, Gemini CLI, they're not close. You can't be close to the leader when you just copy their feature set over and over. We have powerful compute that runs especially well inside of their custom built agent harness, Claude Code. And so this powerful prompt runs 3 steps, right? We have a scouter where we're looking for files that we need to satisfy the user prompt. And we do this because we want to pull out some of that work that the planner is doing, right? Now the planner, if we go into the plan with docs, planner now has a couple very powerful variables it can just read. User prompt, documentation URLs passes all the way into that. And then we have the relevant files collection. And so this was our scout output. It's not just saying what files need to be updated. It's actually going in and it's saying what's the offset and how many characters you need to read to get the valuable information. And so we had multiple agents take a swing at that. We then have a couple static variables in this prompt, plan output and documentation output. And then we have our full-on instructions and our workflow. And then finally, we have our build. Build is a higher order prompt where we pass a prompt into a prompt. We've talked about this on the channel in the past. Check out previous videos to get caught up with this. And this is our Scout workflow. And this is the power of a great agentic coding tool like Claude Code. You can't do this with these other tools. So we ran this great prompt, a simple high to mid-level prompt, and all this work is done for us agentically. Documentation got read, yada, yada, yada. Now, something important to call out here, if I type /context, there's something that I want to show you here. Claude Code has added this auto compact buffer feature. There's 22% of my context window absolutely cooked. So let's talk about that more in just a second. What I wanted to get to originally here is look at my messages. 51% context used by this agentic workflow. Again, in tactical agentic coding, we solve this problem completely by using dedicated AI developer workflows. We combined the old world of raw code with the new world of agents. We put them together and we isolate our agent's context window. Those are big ideas we talk about inside of tactical agentic coding. There's a problem with this, right? There are limits to this, and the limit is, of course, the context window. Our primary agent, even with our delegation, still consumed some 50% of our context window, right? Imagine if we push this further. Imagine if we had a larger code base here that we had to work through. Imagine if our prompt was even more detailed, which it certainly could have been, right? This is a massive limitation of single individual agents. This is why we scale up to out-loop agentic systems, and we'll take a look at the results from our out loop system in just a second here. I just want to mention that this chained agentic prompt workflow, it has limits. The limit is your context window of your agent, and it's amplified and even more restricted here by this auto compact buffer coming out of the Claude Code tool. So there is a setting inside of Claude Code. If we open up a new instance here, open up Claude Code, and then we type /config, you can see we have auto compact true. With auto compact true, if you type /context, and let me just shrink this so we can see a little bit better, you can see we have auto compact 22% of our context window is gone. Okay, this is a huge detractor from Claude Code, but of course the Claude Code team knows that this is a precious resource for anyone using agents, and so you can just turn this off. And so this is what I do. So show compact or auto compact, I just turn this off. If you turn this off and then run context again, check this out. We have that full 91% free, just like we want. The only thing in here is our custom agents, a few setup messages, and the built-in system prompt system tools, right? This is what you want. You want a focused, clear agent with as many tokens as you can spend. Yeah, we were 14% away from exploding our context here in our scout plan build large agentic workflow, right? And again, ADWs are the solution for this. The context window is a hard limit for us in the age of agents. We have to respect this and we have to work around it. And we always must observe what our agent can see. What is your agent's perspective? Does it have space? Does it have tools? Does it have the right model? Does it have the right core for? These are the big ideas we have to focus on as agentic engineers. We need to understand what our tools can do and what their limitations are so that we can understand what we can do and what our limitations are. There is a direct causal link between your ability to control, build, and use agents and your engineering output. Okay, if you don't believe me, you're on the wrong channel. What's next here? So all 4 tested agents are now working perfectly. You can see here I have a specialized output style, Claude Code 2.0, fantastic release. But something I noticed that I didn't like at all is that they are hard truncating a lot of the output from your agent as it runs, right? They want to keep it more clean and concise and compact. I understand that product perspective, but I think maybe taking Claude Code in a little too broad of a direction here, trying to make it the tool for everyone, not just the tool for engineers. We'll see how that progresses. As an engineer, just like I was saying, you want to be able to understand exactly what your tool can do, and it helps to know that by just seeing all the output. So you can see here, I've designed an output style, and I'll go ahead and share this. You know, I can't share this code base. It's for engineers inside of Tactical Agentic Coding, but I will go ahead and share my output style with you here. Observable, tools, diffs, TTS. So this is a 3 format output style. You get all 3 of these: diff reports, you get ordered tool calls, and you get audio task summary. You can see here we got our tools, and since our last prompt was only running, there was no diffs to report. Link will be in the description if you're interested in this Claude Code output style. If you're inside Agentic Horizon, you're going to see the updated Claude Agent SDK syntax here. Thanks to this workflow that you saw in this video, right? Single prompt, and this work is now done. I'll do a little bit more testing off screen just to make sure everything looks good. Let's turn to our out loop system. What happened here? Our agent did everything. They shipped this for us end to end. So let's see exactly what we got. I'm going to copy this, go ahead, hit new, temp, clone, cd open. Let's go ahead and check this out in Cursor. Let's see what our agents built for us. We have our 3 agents that we requested. And just for clarity, let me just copy this, throw this in this file, and you can see exactly what we prompted here, right? So we wanted 3 OpenAI agent SDKs, one with a web search tool, the other with a function tool. This is like a custom tool. And then we wanted to check out the OpenAI real-time agent. And this is something I'll do, by the way, when I'm prompting agents and doing rapid prototyping. I'll have the agent build something simple, validate it, and then build something more complex, validate that, and continue upward, right? Just like with an engineer, right? A junior engineer or an intern, or even a full-time senior principal engineer, right? It's much easier to start with a simple working thing than it is to skip to something potentially complex. Let's go ahead and see how this worked though, right? We have a couple files here. Let's just go ahead and run them. UV run. Let's run our basic agent with web search. I'm not even going to look at what's in that. Let's just run it. And we need an OpenAI API key. There's my export command, up, run it again, and we're running our agent with our web search tool. There's a query. What are the latest developments in AI agents 2025? There's a result, 2 total turns. It looks like we have a decent lineup here. Perfect. Yeah. So the top news announcement, this is something we can easily lean on as ground truth. Claude 4.5 Sonnet. So this is working great. We have this web search tool inside of the Agent SDK, and again, out the loop on my dedicated agent device. I just wrote a prompt and I said, set this up for me. Teach me exactly how this works, right? And so my agents are doing that exactly. Let's go ahead and see how far our agent pushed it, right? Did we get all the way to the real-time voice? Let's see. So let's copy this one. This is the agent function tools, UV run. I assume it just has a couple simple examples here of tool uses, get user info. So if I just copy this, I assume this will be a local user tool. Yep, that's exactly what's happening here. And this is how you set up, OpenAI's Agent SDK with a custom tool. This is the one that I really wanted to test. Let's see how this works. Full audio will require additional libraries. Okay, so this may not work. This is easily the most complex one. There's our response. Let's run this and let's see how far we get here with our real-time API. Let's see what's happening here. Processing events real time. So it looks like there's more work to be done here. I wonder if there's some simple like string pass-in we can set up here. So I'm just going to spin up a quick Claude instance here and say, set up a quick example of how. Great. So we have the AI docs in this directory. I'm just going to link this POC working, set up some quick audio implementation. And so we're just going to give this one shot. It just requires multiple prompts. We'll take this to the back end and work on that. The big idea here is with a single prompt, we can set up entire environments and have our agent execute inside of these environments, right? You saw it here, right? Our agent fired off this job and it went right to my dedicated agent device, right on my M4 Mac Mini. And you can see we got live updates in 60-second intervals from when we kicked this off. And so if we pull down our actual agent device, you can see top to bottom, everything that happened here, right? There's the GitHub URL that got mounted. There's all the documentation. There's our args. I have a full log here. What I want to show you here is an advantage you can start building out right now for your engineering work, for your team's work, for your company's work. You really want to have a dedicated agent device that runs and builds and does engineering work on your behalf. You don't need to sit in the loop for every single task that you're working on, right? If we just scroll down here, we can see we had our plan build. Let me turn on regex. And we also had our ship agent, which did our actual git push, right? So you can just see line by line, piece by piece, inside of my agent device, it completed work. It has output files. I can trace the entire process and it's all backed by a database. We go into a ton of detail into how to build your dedicated agent device, how to get out the loop. And we do that inside of Tactical Agentic Coding. This is my take on how to build with agents to scale beyond AI coding and vibe coding with advanced engineering so powerful your code base runs itself. And I know, simple example, we just set up some proof of concepts, passing in some documentation, but I can guarantee you can push this a lot further. I push this a lot further. I want you to have this massive advantage here. A lot of engineers are going to miss this, okay? At first glance, sitting here inside the loop with your agent feels really good, right? It feels like you're doing a lot of work. But once you realize you can set up better agents, more agents, and then custom agents, I have this feeling now when I'm prompting back and forth with a single agent, wow, I'm wasting time. How can I scale this up? How can I add more compute? How can I add more agents? How can I build a custom agent that does this better than any agent does running inside the loop? That's what Tactical Agentic Coding is all about, all right? This is for engineers that ship. And, by the way, I should just stop and say, this has been out for 1 week and we have hundreds of engineers inside of this course already. Big shout out to everyone who's taken Tactical Agentic Coding and that's gotten value and started moving on the new system that is more important to build than anything. What if your code base could ship itself? That is the big idea here. This is not for everyone. This is not for beginners. The whole idea here is really simple. We need to let go of the old ways of engineering and we need to master the new best tool for engineering, agents. Okay. And the big idea we talk about throughout Tactical Agentic Coding is you want to build the system that builds the system. Okay. And what did we just do here in a really kind of small microcosm example? We used a system that is just on, we passed a prompt to it, and it did arbitrary engineering work for us. Now, to be super clear, this code base did not exist before I ran this prompt. This workflow created this code base, right? So I could have prompted anything, right? I really could have said and asked for anything. This is a differentiating advantage for engineers. We're talking about asymmetric returns on your engineering time, okay? I wrote 2 prompts and then I just talked to you about what happened. Some engineers that have taken Tactical Agentic Coding, they're starting to build their new layer around their code base. They're starting to build out and use the tactics. Your engineering output is going to be absolutely mind-boggling once you start using the tactics of agentic coding, okay? So just a couple things to mention here. This is about building the system that builds the system. It's about focusing on the agentic portion, the agentic system in your code base, and letting that do the building for you. To be super clear, this starts with your reusable prompts, right? You saw that here inside of our building specialized agents code base. Another great feature out of Claude Code, Control R, backtick search. I can now say AFK, right? There's our AFK prompt there. And I can also look for our scout, right? So there's that scout prompt that we ran. You can see here, this prompt was a perfect example of building up just a little bit piece by piece, right? We're composing prompts. It's a perfect example of if you invest in the prompt, right, and you understand what you can do with agentic prompts, you can then have your system build your application, right? And that's the big idea here. And we go into serious depth in tactical agentic coding. We talk about scaling the core 4. We have the 8-lesson core. This is where we talk about the big ideas, build the system that builds the system. And then we have agentic horizon. So I mentioned this a couple times. This is where you're going to find the elite context engineering and the agentic prompt engineering. And of course, the building specialized agents code base. This is an additional product you can buy inside of tactical agentic coding. Right now, we still have a couple of deals running. By the time you see this, it's probably going to be down to 9 or 8 or something. But there's 2 deals. If you're a principled AI coding member, you have an additional deal. But if you're not a principled AI coding member, and you'll know if you are, if you're not, you're still good to go for the early bird special. If you're not a member, you will not have both discounts. Let me just say that loud and clear. There was some confusion on the previous video. So I'm just be super upfront about that. There are no tricks. There are no gimmicks here. I am trying to get the great engineers who invest in themselves as soon as they see an opportunity, the opportunity to do that. All right. Hop in this course. We talk about building with agents and we scale far beyond this back and forth prompting that so many engineers think is oh so powerful. And it is powerful, but it's just the beginning. It truly is just the beginning. So this has been a short agentic coding session. I only ran 2 real prompts, a couple follow-up prompts just to clean up. I'm super curious to see if we get a full completion here out of the real-time API. It looks like I got a great start. Again, my agent just put this together for me. 200, 300, 500 lines of code to start out this proof of concept. All right. So this looks like an okay starting point. Of course, an agent box with no audio probably would not get far on a task like this. So I'll have to push this forward. But this is fantastic. Check out the links in the description to get started with tactical agentic coding. Keep your eyes focused on the most important tools. Don't get caught up in the hype. Claude 4.5 Sonnet is in fact the best coding model in the world. And on top of that, inside of Claude Code, it is the best agentic coding model. It's the best agentic model. You can set up long chains, long workflows that run end-to-end work on your behalf, on your device, and inside of dedicated agent environments. These are big ideas we're going to be talking about on the channel. Make sure you're subscribed. Make sure you're tuned in. We have everything we need to get massive value out of our agents. Now it's time to put the work in and build powerful systems that operate on our behalf. Thanks for watching. I'll see you in the next one. Stay focused and keep building.